Hello, everyone. Happy Friday. We are back for another distributed tea time. As always, I'm Adrian Howard, a developer advocate at CockroachDB.
And I'm Rob Reed, Technical Evangelist at CockroachDB.
And on cue, there's Atticus.
Yep.
He'll be going up and down the stairs at his leisure.
Chief
Um,
Barking Officer at
yeah,
Cockroach
chief,
Labs.
yeah, chief bark officer. I think that's what I have on his title. Um, Yeah, so today we want to talk about JSON and what to do with it, specifically in a database table. And so we'll be diving into how we use a JSON B column. We have kind of a short demonstration of why you might be wanting to store JSON. And then Rob has a lot of information to give you about what to do with the JSON once it's in the database. Anything else, Rob?
I think that was it. I think
All right.
that was it. It always seems weird talking about Jason and then saying it. I always think to hear the name Jason and think we should be talking in terms of him.
I know.
What you can do with him.
I try to be like Jason and Jason, Jason and Jason, and sometimes I call Jason just by accident. Like, luckily I don't
When you
know
say
a lot
Jason,
of
it sounds really British.
them.
Maybe I should
I have a
say
muddled
Jason.
accent. That's what I get for traveling a lot when I was younger and going to college with a lot of people from Minnesota. Um, yeah, so my
I can
Hoosier
still hear
accent.
your Indiana twang. It's still in
Yeah.
there somewhere.
I still have a little bit. Sometimes I throw it out there, like with the howdies and everything. Yeah, so there are a number of reasons why you would want to store a JSON object in a table. A lot of times people will normalize the data, but with API access, a lot of times you don't know when those responses are going to change, or maybe they're not uniform. And so let's start with the demo. I put together a simple demo, again, another remix application. Let me share my screen here. And so this is just using the Spotify API. And if you haven't used the Spotify API, it's really fun to use. I think you do need to be a Spotify premium member, but I started out with a simple login because that's the easiest way to get an access token. So I'm going to log in with Spotify. And we have this little app. So what it allows us to do is search for an artist. I wanted to do something like, give me like some random songs or something like that, but the API just didn't have that. And so we're going to start with an artist.
Before you get going, can I just
yeah.
call everyone's attention to the exceptional logo in the middle of the page?
That's
My
right.
daughter drew this for Father's Day, and I have
okay.
it. I sport it proudly on a T-shirt.
Wait, we can. Why are these not working? Yes.
Look at that.
Mm-hmm. Yeah.
Courtesy of Ruby. Thank you, Ruby.
Now how do I go back to the? We have
Actual
fun
size.
here. Okay, actual size. So I'm gonna search for an artist. I think no surprise to Rob. I'm gonna type Taylor for Taylor Swift. We will be
didn't know you
presented
liked
with
her,
some
but-
artists. You didn't?
No.
And well, so I'm gonna choose her. And we got some tracks here. So these are her top tracks by popularity. Cruel Summer really making a comeback. If there's any Swifties out there, this was released like a few years ago, and it actually it wasn't even released as a single, but it hit the top 10, and it was like the first Lover album to hit. Anyway, I could go on
When you
and
said
on.
it's making a comeback, I thought you were talking about the original Bananarama.
Bananarama?
Cruel Summer. Was it Bananarama?
Oh, I know that one
yeah, I'm
too.
pretty sure. Cruel
Yeah.
Summer. The original. The better version,
The better
if I may.
I mean, I like that one too. So what we can do is we can favorite tracks, and so we have where you can favorite them. You can remove the favorite. There's a little heartbreaking when you do it, and then you can add a couple more. Oh, Cardigan. Let's see, a little Karma, and then we can go back and find another artist. What's another artist? Let's see. Let's do Dolly. All right, Dolly Parton just released a rock album. Let's
Ooh,
add some
edgy.
9 to 5, some Jolene, And do we want? Let's one more artist. What's another good artist?
Anal Nathrak.
A what?
Anaal.
Uh-huh.
And then, can you search for that?
Let's
Obviously,
see.
bit of a risky search, but Anal Nathrak. There we go. Of Horror
Okay.
and the Black Shawls.
All right. Any favorite songs here? I've not
Of
listened
Horror
to
and the
these.
Black Shawls. It's my favorite song in the world ever.
Ahura and the Black Shores.
Of Horror and the Black Shawls.
I don't think it. Oh, it's not one of the top ones.
It's not. Oh. Well,
I mean, that's how you can tell you're a deep fan. You know, or you're a real fan. You know those deep cuts. Oh well.
How could you not favorite such a song?
We'll just do this one. Hold your children close and pray for oblivion. Okay, so now that we've got some items favorited, I can go in and look at my liked tracks, and here they all are. And so every time we were liking one of these, we were saving the whole JSON object as a track to the database and then connecting to that. So we did set it up to where it's a many-to-many relationship, so that way if multiple people like the same song, we're not duplicating data in the tracks. So that's nice. So this is the app. Very simple. We're just liking things and shoving JSON into a database. So let's take a look at the database. So if we want to show tables here, so here's our tables, and actually what might look a little better is if you are a schema person, here is the schema for Prisma. So we've got user model, track model, and tracks for users, which is our little joining table that we use for the many-to-many relationship. That gets compiled into a migration, which is the stuff that Rob likes. So here is all of the SQL to create the tables. And then if you are using Prisma, we are using something called a computed column. And so you can actually go in to this migration file after it's generated and make that change, since there's not native support for computed columns yet.
Just a quick one on that. If Prisma regenerates, does it keep your changes or does it nuke them?
No, every time you make changes, you have to create a new migration, and it just layers it on.
I see.
So it would only change that if you change the field. So it keeps
That's
it.
nice.
And so here you see we have our tracks table, and for the ID, you see we've got this little expression that Rob will go into, but basically what we're saying is from data, which is a JSON-B column, we want to pull out the ID and store it as a computed column. That allows us to do things like make it a primary key. You'll hear more about that shortly. So let's take a look at the data. Let's go back
That's
over
quite
here.
a cool feature. I don't think it's limited to Cockroach, but the fact that you can lift a field out of JSON and set it as a primary key on a table, I think that's quite powerful.
Yeah, and I really like anything that like moves the stuff away from the developer and into the database, right? So like a developer doesn't have to manually pull those fields out of the JSON and write them. You can just do a query in there, and so that way I think it's easy to change around because you can do it with a migration script. So if we were to show star from tracks, we would get just a lot. Oh. Wow, show select. Just a reminder, it is 9:40 here in Manhattan.
There's never an excuse for getting select and show missing stuff.
Yeah.
Surely, no, I'm just joking.
So here's, as you can see,
A wall
lots
of text.
lots of wall of text, lots of JSON information. But Rob was so kindly to give me a query to display it all looking nicely. So here's the query. We're selecting some items or pulling some things out of JSON, doing a nice little join, and we get, ta-da! We get the track ID, the artist names, the album name, and the song name. So that is a great way to be able to query things out of the JSON blob in like a structured way. And very quickly I will show you how I did this, how you can do this with Prisma, because Prisma doesn't go this deep into selecting from JSON, and so you can do something. You can use their query raw, so that's their little escape hatch to be able to query things directly. And the example that I have is, here we go. So whenever you hit the like button, we have to write a new record to the tracks table. Because the ID is both a primary key and a computed column, we can't use the Prisma create function, because if you pass the ID, you'll get an error saying that you can't write into a computed column. And so to get around that, I'm just using this prisma.queryRaw, and I'm typing it, so I'm saying that it's going to return an object array with an ID that's a string. And so I'm just doing an upsert into tracks. I'm giving it the artist ID and the data with the values of the artist ID, and we're JSON stringifying the track information. So the track comes from the Spotify API. So here we grab the track, spotify.tracks.getTrack by ID. And then we are upserting that, and it will return. I have the returning here. So the cool thing about CockroachDB, and I think Postgres in general, is you can add a returning clause to like return whatever information you want, and you can add more than just that ID. And that's actually one of the reasons why Prisma in their latest release updated some query optimizations for CockroachDB and Postgres, because previously they would write to the table and then they would pull everything, then they make another query to pull everything back out, and they've changed their engine to use this returning expression to pull it out. So we've gotten rid of a query. Obviously speeds things up. And then afterwards, I'm using the Prisma functionality to add a reference to the track ID and the user ID, so that way you see it's my-like. And I'm doing an upsert here, so if you somehow are able to like the same thing twice, it's not going to create a new record. So we can see we only have a create. So if there's no conflict with the user ID and the track ID, then it will create. Otherwise, it's just going to do nothing. And that's how you get around this. So if we wanted to use the query that Rob just gave me, we could do the query raw, add that in as the string, and then if you want, you can go as far as typing the results so it's all nice and works with TypeScript. But again, you can use that escape hatch to get this stuff out in that fashion. So for anything that Prisma can't handle, because I believe it's just using like the underlying Postgres client, which might be Node Postgres. I need to look into it. Did I cover everything, Rob?
I think you did.
Awesome.
I think you did. Yep, nothing that I won't be covering in a second.
Right. Covering a little more. So I'm going to hand it over to Rob, where he's really going to dive into how to best use JSON in the database.
Thank you.
Yeah.
So I have generated a bunch of data, 100,000 random people. I love my really contrived, stupid examples. So I'm dealing with people. And if I show you, I've got 100,000 of these. Each has a random UUID, each has a random full name, and each has a random JSON blob representing their address. These are completely fictional people. Give it a go, look them up. You won't find them. Well, you might find the odd person, but anyway, I generate it using a tool called DG, a tool that I wrote a little while ago that does this. It's super helpful, although I would say that. So 100,000 people, I generate an ID, and I generate a full name, and then I generate some basic just JSON randomness. So I will close that down because I don't think that's particularly useful once you've seen it. And I'll close this one down because I don't think it's particularly useful since you've seen it. And I'm going to start a web server that is going to serve that file up to me. So I'll start that. And now I'm going to start creating stuff in Cockroach. So I'm going to start an insecure cluster. Ooh, it's already in use. Let's not kill it. Nice. Let's do a key kill. Die.
I'm not surprised that Rob already has a local instance running.
Oh, always. So I'm going to create my contrived person table. It has its ID, full name, and contact. The primary key is the ID, and it's generated if it's not provided, but I'm providing it for all of them. With that created, I'm going to run an import statement. So import into the person table these columns from CSV data at this URL, and skip one, which is the heading. If I provide an empty string, I get null, although there aren't any empty strings, and I allow for quoted nulls, which I think allows that.
I need to point this out. That's really clever. So I do a lot of hackathons, and at the hackathons, we struggle to import CSV data because we have to like save it somewhere where we can get it, or we have to try to figure out the user file. But you just spun up a server, a local server, and served it so we can just grab it from there. I need to remember this little trick. Anyone
with Python, if you go to codingconcept/DG in GitHub, my GitHub repo, you'll see that there's a walkthrough on how to do this locally. So as long as you've got Python 2 or 3 installed, you'll be able to do this. The syntax is slightly different for Python 2, but it's largely equivalent.
Brilliant.
So now I've got a bunch of data. So I'm going to select everything from, I'm going to select the contact from the person table, but I'll limit it to 3. So this is 3 random 3 entries in the database. What a horror show that must be. I live in South Neckland. Just South Ford's side, South Tunnel. There's a lot of south. Everything's very south, but South Neckland. What a horror show. Anyway,
I live close to Great Neck, New York.
That's less. Yeah, maybe it's South Neckland though. It sounds weird. Anywho, we can interrogate different parts of this JSON. We can pull out whatever fields we want. We can update specific fields. We can access array elements. We can update array elements. You can do pretty much anything you'd want to be able to do over a JSON object. And what I'll do here, I'm going to start pulling out JSON data. So let's get the address out of there. So this syntax here is the syntax in Cockroach for accessing a bit of JSON within a bit of JSON. So this accesses the address JSON object within the contact JSON field. So if I run that, it returns a JSON-B object. And I should qualify that JSON and JSON-B in Cockroach are the same thing. They're just aliases of one another. So that's why when I created the table, I created it as a JSON column and not a JSON-B column. I could have used either. So that returns, so the hyphen arrow syntax returns a JSON object. But if I wanted to get a specific value out of there, and I know that, let's say I want to get zip, this will return the underlying type. So this will return me an integer. Whereas if that was a string, let's say I wanted country, it would return the country value. If I were to, let's say, return, I'll show you what it looks like if I don't do that. So if I return country, it will return it as a string. But if I return, if I ask for the JSON equivalent, it will return the JSON value of that, which is a quoted string, which you found earlier.
Yeah. Yes.
So I will show you why this isn't particularly performant. So I haven't got any indexes on it. I'm just querying JSON, and it's not terrible performance. I'm asking for 3 values. It's taking a millisecond, but over time that will get slower. And if I ask for more data or my query is more complicated, it will grind to a halt. So let's count the number of people in the table whose zip is this number here. Okay, we've got 1 person, but it took 91 milliseconds. It's taken a while to do. And if I run an explain on that, we'll see that we processed a bunch of data. We iterated across the whole 100,000 rows. So you imagine that goes up to 1 billion. We're iterating over 1 billion people, and we're doing a full table scan. So it's not ideal. So there are a bunch of ways we can fix this. We're gonna, and I'll take you through 3 different ways that you can basically improve on the query performance. There's one way of doing it that I'd recommend over the others, simply because it's more flexible, but I'll show you them all anyway. So
and just to remind people, what is the kind of the millisecond limit that we're aiming for anytime we're optimizing our queries?
Good shout. So the end-to-end request shouldn't ideally take longer than 100 milliseconds if possible. There is a unwritten rule that states that if your request is taking longer than 100 milliseconds, it's generally perceivable to the user. And if it's perceivable by the user, it's going to start to be annoying. If you're having to do everything, like if you're, let's say you're browsing Amazon and every time you scroll the page, it's like jerky and waits. You're going to get frustrated with it. It's not going to feel natural. If you start typing in the keyboard and there's a little lag after every key you press, it's going to get frustrating. So yeah, aim to have all your requests complete within 100 milliseconds. But this is just the database part, so always aim to have it in the low milliseconds, like single-digit milliseconds ideally.
In the good old days, we would just throw up a animated loader, and everybody would be happy with that. But no more.
No, I think we've just fallen out of love with the animated loader.
I guess.
First way of doing it, the option 1 is to create a column and lift a value out of the JSON. This is what Adrian did in his previous example to lift out the primary key identifier. So in this example, I'm altering the table person, I'm adding a column called zip, it's an integer, and then there's an expression which pulls out the zip from the address from the contact, casts it to an integer, and it's a stored computer column. So if I create that, and let's do I've got all of these statements here, so I just don't have to keep on typing them out. So now we've got the ID, the full name, and we've got a zip column. So if I show the create table statement, show create, select create statement, statement, show create table person. So we have our ID, our full name, our contact, and our zip, which is an int 8. I could have cast that to an int 2. I don't think, no, the zips go higher than that, so maybe an int 4 would have sufficed. I think that's a 32-bit integer, but we've got a 64-bit integer. But
I know that with when you're working on the front end with JavaScript, anything over an int 4 is annoying because then it brings in the big int, which big int isn't natively to JSON stringified. Yeah. So.
Yeah, and it's quite a big difference. There's quite a jump between the max JavaScript value and the max int 64 value.
Yeah.
So I'll do the same query again, but I'm now querying against the zip column. Any guesses as to how long this will take?
A millisecond.
No, it is faster, but it's taking about 40 milliseconds. And that's because I don't have the index on there yet. So if I was to do an explain on there, it's going to suggest to me that I need to create an index over the person table. So I'll do that. Let's got it all copied.
So this is another thing where if you weren't looking at all the explains, you would probably see this in the console under what we call intelligent insights.
You would see it, yeah, exactly, and that's a really good point. We are monitoring your SQL workloads, and we do surface up in an anonymized way, so you don't get any PII, personally identifiable information. But we do surface queries that are underperforming, and you can set the limit to which you consider a query to be underperforming. So yes, it's set a low, I think by default it's 100 milliseconds. Anything that takes over 100 milliseconds, it enters the process of the insights and the workload insights. So we would start to look at and monitor those queries for you, and as you say, flag them up. But if it makes it into production and it's already slow, obviously we'll show you, but ideally you would have the tool, we provide the tools so that you don't run into that. So I've created an index on that now, and yeah, 1 millisecond. So it might take 2 milliseconds, 3 milliseconds, but we're in the single digit milliseconds, and that's much better. So if I do an explain over that now you can see we went directly to the data that we asked for. So CockroachDB was able to go to the range that it cared about, and only that. So we ended up scanning, we actually scanned 1 row instead of 100,000. So much better.
Yes.
We can do better. So this next example isn't going to be better, but we will get better. So first I'll drop the person index because we don't need to do that. CockroachDB will clean up any space from that index in the background. But now I'm going to do the same query again. So I'm going to be asking for contact address and zip, and I would expect it to take around the 90 millisecond, 100 millisecond mark, which it does. But this time I'm going to create what's called an expression index. So whenever you make an expression, we've indexed it for you already. So I'll create this index, and then I'm going to run a query. And this query is now super quick. Whenever you do this exact expression, it's super quick. But why might that not be ideal? it's only for the field that I've
Mm-hmm.
indexed. So it's only for the exact expression that I've given. So it's not particularly flexible. So you might save on space, especially if you've got a very, very large JSON document. Having these expressions, and you're only using, so like I'd recommend both option 1 and 2 if the JSON object you're working against is huge and you don't want to index the whole thing, and your queries, the things you're querying aren't going to change often. So if you're always going to be doing a query for zip, or you're always going to be doing a query for country, then create those expression indexes. They work really well. But if you've got a huge whacking great JSON document and you're not querying over most of it, it probably doesn't make sense. And I'll just do one more thing. We can see that we've used the person expression index, and again we've resolved that we were looking for this zip because the expression was indexed, and we only brought out that exact thing, and we scanned over a tiny subset of the 100,000 rows. We can do better.
Do you think it was less than a millisecond, and we just don't like report that small? Is that what we're seeing?
What do you mean?
So every time that you're running this, it's saying like time 1 millisecond total, and you're like, we can do better.
Oh, I see.
And
oh no, when I say we can do better, I mean,
oh, okay.
I'm gonna change the query to make it more flexible. But I don't think you should always do it in the option 3 way.
Okay.
I think it really depends on your workload. But I will do that now. So I'm going to delete the expression that we just used to speed up that query, and again it will be reclaimed in the background. And now I'm going to create an inverted index, or a general inverted index. I think that in inverted is the in
in, yeah.
But this is a GIN index.
So in the documentation, you might see it as a GIN index. Yeah.
Yeah, and they're the same thing. I could create a GIN index. I can create an inverted index, but ultimately they are the same thing. So I'll create an inverted index on this.
And what is an inverted index?
So essentially, it's index.
Hey, Ruby.
Hey, Ru. Do you want to say hello to the people watching our stream? Ruby, I'm streaming. Do you want to say hi to everyone? You want to wave? Go on. Off you pop. Right. Maybe later. Yeah. Off you go. You can have some later. If you don't go now, you can't have some later. Thank you. Anywho, so I've created an inverted index. You asked what an inverted index is. Basically, it creates an index on the fields within the JSON object. So you'll have an index over address, you'd have an index over zip, you'd have an index over country. It makes it super flexible because it allows you to do queries over things you might not necessarily know you need to query at creation time. But the index will be larger because you're indexing more things. So I've created that now, and what do you think? How do you think this will now perform if I do a search for contact address zip?
Another 1 millisecond.
Unfortunately, not. No,
Oh.
it's going to actually be slow, and that's because I'm using this syntax. Whereas now that I've created an inverted index, the syntax needs to slightly change, and that's no problem. We can do that quite easily.
Okay.
So I'm now scanning over 100,000 rows again, and I'm doing a full table scan. So it's not ideal, but the way around it is quite elegant. So now we use this syntax, and it's basically a contains, and it can be used with JSON syntax. So where the JSON, where
And
the contact
that's
JSON,
an @, and is that a closed angle bracket?
That's it, and an arrow. Yeah, I don't know what the bracket. Yeah, bracket. And I'm looking for where the address zip code is 70232. I tried to pick 90210, but it wasn't randomly generated. So I just picked another random one. So now 1 millisecond, 2 milliseconds. So now we're nice and performant again. And it's all thanks to this syntax here. So if you are using an inverted index and you're using JSON columns, make sure you're using this as well, or otherwise you're not going to get the performance benefits of it. It's just going to be doing a full table scan again.
And so this is a change that we made to the where clause. We didn't change anything with the inverted index.
Say that one more time, sorry.
So you created the inverted index, and before you were using a where, what you were doing like zip equal to the zip. But with this one, you're changing the where clause to use this like JSON expression.
Yeah. Yeah. And the beauty of this is now I can ask for anything within the contact JSON. I can ask for where the country is, for example, US. And there are 405 instances of people with an address of US. So yeah, I think there's of the three, a computed column makes the index most table-like, makes it most column-like. You can lift things out of JSON and have them as columns. An expression index will create a very small index for a very specific part of your JSON. And an inverted index is the most flexible. So I think depending on how you need to see the index, how you need to use and access your JSON, it really, you've got some flexibility there. And essentially, you can treat Cockroach as a document store if you want to, because you can store structured and semi-structured and unstructured data in these columns. If, for example, an object doesn't, or a document, let's say, the JSON object doesn't contain a country field, it won't enter into any of the filters, so you just won't see it. And I'll show you that now.
Oh, nice.
Well, I'll show you that in a second. First, I'm going to do a couple of queries that demonstrate what the JSON looks like and how you can prettify it from the database. So here, I'm asking for the full name and the pretty version of the contact data from the person table, and I'm going to limit it by 3. So here, we see the full name and the pretty version of their address. So it's a little bit nicer to look at than just that JSON blob, and it's useful for debugging purposes, I think, but if you're in the real world, you'll probably want it minified, so you'll want the default behavior of JSON. You'll just want to ask for the JSON column because you're only going to be interrogating fields. But that might not be particularly useful for you, because this is returning 3 different JSON objects that you're going to have to, in your JavaScript front end, say, okay, parse this JSON, parse this JSON, parse this JSON. It's probably better to return it as one big block, and that's what this query does. So if I create my JSON object, and then I'm going to prettify the result of aggregating them together. So if I show you that, so this returns one big block of the same data. There's South Neckland, but it's all in one array. So I've got an array of objects this time, so it's one row. So you can just ingest it into your front end, deserialize it once, and then start accessing it as an array.
Oh, that's
a little bit more
nice.
friendly. And you can build your own. You don't have to just use this JSON column. You can build your own. So in here, I'm going to prettify it again just for the demo. It's a bit nicer to look at, but I'm going to build a JSON object this time. So I'm going to create a field called ID, whose value is going to be from the ID column. I'm going to create a full name JSON value, whose name is going to be coming from the full name column. And then I'm just going to use the rest of the JSON contact data to return the next. And it will all get added into one object. So as in for each row. So I've got my full name, I've got my ID. So you can build up your own JSON objects. You can.
And it's important to note that the column names use single quotes and the values use double quotes. Because
or not.
Unlike in JavaScript, they're not interchangeable, right?
They're not. So in Cockroach, if you're using double quotes, it will try to look for a table name or a column. And if that doesn't exist, it will say the column or table doesn't exist. I use double quotes as a force of habit, really. There's no reason I should use them. I just prefer how they look. They will look like strings, as opposed to some things like, for example, data is syntax highlighted in my editor, or in SQL. Or user underscore ID is syntax highlighted in a different color. It just looks all a bit of a mess. So I prefer to see things all in one color. And I can ask for different things. So if I just want the address and zip, I'll only get, oh, you didn't find the zip. Oh, it's because I didn't ask for it as a string. So, but it's asking it for it as a string. That's interesting. Let's see what it does if I just ask for the JSON value. There we go, that's better. So something to note, if you're creating a JSON object, make sure you're using the JSON version of the JSON object version of the field. So in here, I'm just returning the information that I care about. So I'm not returning the whole blob. Yes.
So this is very handy if you're making queries for a front end person. So I know when I worked for a document database company, like the good thing about what was coming out of there was exactly what the front end person needed. So I know there's a lot of situations where I can pull the information out, but then I might have to like map over it to create it, to change it into the way I want it. And so that's where like this JSON build object is very powerful, right? Because you don't even need to use it with a JSON B column. You could build a JSON object from anything, right?
Yeah, you can. Yeah, and it works with joins as well. So if you want to pick and choose data from different tables and aggregate it all together into a JSON object, that's fine as well.
Yeah. Nice.
The last thing I'm going to show you is updates. So this query here will set will add a state value to any users in the person table whose country is US. I'm just setting California for all of them for now. And this true flag means create it if it doesn't exist. If it does already exist, that can become false, but I don't think there's any reason why you'd want to
so this JSON B set kind of acts like an upsert.
I'm not sure on the exact semantics, but I see what you mean. With the true, yes.
Yeah.
I see what you mean. Yeah. So I've now set that the 405 users who were in the States have now been updated. And if I show you the top 10 US people now, so I'm going to ask for the full name, the country, and the state thing where the contact country is US. And we get 10 of our 405 records.
Nice.
But you can also filter it in this way as well. So I could say, give me everything, the country, the state, the full name, where the contact has a state value or contains a state value. And this will return something similar. It's just a shortcut to say, rather than having to look for a different field, which works in conjunction with that state field, i.e. the country being US, I can just say, do you have a state column? And therefore I can work against quite amorphous data and unstructured data, because I can ask for only the stuff that I'm interested in.
That's really cool.
That concludes my side of the demo.
That is a lot more functionality than I originally thought we had.
And there's more. I think I've scratched the surface.
Yeah.
I haven't gone into any of the array manipulation stuff. I haven't gone into the other syntax. Like there's more than just this, and there's more than just this. There are other ways of interacting with JSON, but I think just to whet the appetite, go through a couple of things, and maybe link to the docs, because there are a lot more things you can do. And if you go to the functions and operators page, there's a bunch of other JSON specific tooling you can use to manipulate JSON.
Yeah, we'll make sure to add the link to the JSON docs in the description below. See, MongoDB has a schema validation feature. Does CRDB have any such option, or do you have to do it yourself server side?
Honestly, not sure. That's a really good question. I'm not sure. I'd need to look it up.
Yeah. No, that's interesting. So with me, like most of the time when I'm storing a JSON blob, it's when I'm getting information from an API call, and I want to store the whole call because I don't know if I'm going to need the values later. I guess, have you seen any other examples of why people were using JSON-B? I mean, we have such a rich set of functionality for like being able to add it and manipulate the data, change the data, update the data. Do you know any other use cases for using it?
I think yours is probably the most obvious use case. I think if you don't know what your data is going to look like, or you have data that might change over time, I think it's a double-edged sword, because with CockroachDB you've got online schema changes or live schema changes, so you can make changes like even modifying primary keys without any downtime. So you can perform updates safely in Cockroach without taking it offline. So from that perspective, it kind of diminishes the value somewhat of or that argument. But I think if you don't know what your schema is going to look like, or you want to have a loose, semi-structured schema, then JSON works really nicely. You can enforce the schema. So for example, with the example where I lifted out the zip and Adrian lifted out the ID, if you try to insert a value where I can do it now. So if I try to insert into person let's do the idea will get generated, but let's say the data is empty. Just make it an empty document. Oh, it's called contact.
Yeah, mine was called data.
Oh, no, I need a full name. Full name. And let's say Robert. Did I? Oh, I've removed my column. I've removed the actually, do I? Hang on, let me show create table person. Oh, it's not. It's nullable. That's why. If I'd made that non-nullable or a primary key, for example, that would have moaned. So maybe it'd be worth trying just to demonstrate the point. Yeah. Let's drop the table, alter table person, drop column zip. I need to enable set SQL safe update false. That basically allows me to perform unsafe operations in my session. So I'll create that, but now I'll say null. Okay, it's already failed because the value I just tried to insert has a null value. So that wouldn't have allowed me to create it at insert time. Let's say I had created it and all my zips were populated, I would have failed at that point. So there is integrity there still.
Okay.
So I think there's a lot of flexibility. I've used JSON in the past, and my use case was very similar to yours. I was scraping data. I was getting like event-based data from like aircraft live updates to aircraft positions, and I didn't want to have to interrogate the whole data source. I just wanted to dump everything in and then be able to do some processing later. So yes, I think that's a really sensible use case.
Yes, and we still recommend not just having a table with a single column that is JSON. Utilize some of the other features of CockroachDB. Utilize those computed columns.
And it doesn't, because it doesn't tell you anything about your data. If you've got just an ID in a JSON column, it's not very descriptive. You need to have some idea as to what your table contains, and it's not, you know, you're not flexing relational data as it could be with just an ID in a JSON column.
Yeah.
But for anything else, like let's say the person had a full name, a date of birth, or whatever, and then there was a descriptive field, maybe address or something else, maybe not, maybe you'd want to create a separate table for address. But if there was just a blob of data in addition, like metadata for that user, that's potentially a good candidate for JSON.
Yes, yeah. Thinking about like all the different OAuth providers, how they all have kind of their own profile set up. So you could do a profile JSON-B column and just dump that in there and pull out, you know, what you need when you need it. We have a question.
Payment provider is the same. If you make a request to Adyen or something, you get a big old JSON object back, and it's the same with most APIs. You'll get a big old JSON object back, some of which you are legally obliged to store because it's transaction-based data that you need to retain for, I think in the UK, 6 or 7 years. That's another use case for it. You just dump that data straight into a JSON column.
Yeah, because like even like APIs have a certain contract that they're going to return, you know, a certain amount of things, and so you can rely on some of it, but there are some fields that they can turn and like this could be anything.
Or the API contract can change.
Yeah.
So if you're operating against a contract and suddenly that contract changes, if a field goes away, that's obviously a problem, and if you need it, then and you're processing on it, that's a problem. But then you'd hope that would have been negotiated between the either side of the interface first.
Yeah.
But if you've got a schema that can change over time, you don't want to have to keep on making database schema changes. Yeah, it's a good use case.
So we got a question in the chat. It says, any plan to support protobuf in the future? I'm not sure what protobuf is.
Protobuf is Google's serialization mechanism. So rather than, because so people tend to use, have you heard of gRPC?
Yes.
So the G in gRPC, I think, originally stood for good. And then as of version 2, I think, if I'm not mistaken, they changed it to mean great.
Oh.
So yeah, protobuf is a serialization technology that serializes an object into a binary representation of that object, which is a lot quicker to serialize than JSON, and it takes up a lot less space on the wire than JSON. So I've heard stories where people are sending just gigabytes of JSON across the wire, and all of their microservices communicate via JSON, and it's an expensive way of operating. And they found out that it was getting so expensive that they decided to change their service to service serialization mechanism to protobuf, which works quicker, is cheaper because it doesn't use so much data. I don't know of any plans to support protobuf. I know in the background we store things using a proprietary, or rather like a serialization mechanism that is our own, like an encoding a way that we write to disk. But if the question is, are we going to add a protobuf column? I don't think so. Can you store protobuf data in Cockroach? Yes, absolutely. You can just store a binary. So if you're using the bytes table, the bytes column type, you can store protobuf binary data in there, and that would work fine. You'd still want to be able to slurp out the data and deserialize it yourself. Cockroach wouldn't do that for you, but it's completely possible to store protobuf encoded data.
Yeah, and with the bytes column, we recommend keeping that under 1 meg because of all of the replication that happens.
Yep. Yeah, if you've got, and I don't know about JSON, I'd imagine it's probably the same. If you've got more than a megabyte of JSON, I think there's problems. But
I think it's any field if it's more than a megabyte. So
yeah. And when I say it's a problem, like you'd split it out into different columns. You could still store it all, but
change that.
Any other questions from anyone?
Yeah, good questions.
Yeah.
I feel like I need to go back to some of my applications and like switch the way I'm doing things, because I know I have one example where I'm having to use an array reduce to change the format of something. So it's returned as an array of rows, and I need it to be an object with like key values, and so I have to reduce that into an object. Actually, it's the translations. So we store the translations. So if you watched our what was that called? Our global app.
Making your local application global.
Global, yeah. So one of the things that we did was we internationalized the application by adding different translations, which I've updated that. So hopefully we'll get that out as a blog post, and we'll get that example out so people can play around with it. But I did switch it to where you can change languages just by using a dropdown, which is fun. But all of that data that translations data is stored in the database as rows. So you've got, your namespace, your language, your keyword, and your translation, and all of that comes back as rows. I think I'm just selecting out the keyword and the translation because I'm filtering on the namespace and the language, and so I have these rows of keyword and translation, and I need to turn that into an object that is the keyword with the value of the translation. So I'm pulling the information out of the database, but then I'm having to go through a process on the client side to convert that into what I need. So
that happens in your npm package, does it?
Yeah, in the application. Yeah.
So only you have to do it. It wouldn't have to be something that everyone who imports it. Okay, well that's at least something. Yeah. But yeah, well, we can maybe work on that to maybe better harness Cockroach's JSON support if you want to try.
Well, yeah, because we could just we can keep it in the tables that we have, right? But we
return JSON.
Yeah, we can return it as like one row of JSON, right?
Yeah.
Nice.
Yeah, if you wanted to.
Well, I'm totally gonna look into that because I feel like we could probably, because that's something that happens like at startup, or like not startup, but like when the page loads, right? And so whenever you change the language, it has to go through this process of querying the database and building that object again. So if we could speed that up at all, like that's just gonna make things better.
Yeah.
Let's see. I guess my point with the possible protobuf data type would be to enjoy backward and forward schema compatibility working with JSON is almost as painful as working with data store.
Backwards and forwards. Oh, I see. Yeah, because in protobuf you number your fields, so you'd have like ID is 1, first name is 2, whatever. Yes, that would be nice, and I guess that's what you're talking about with Mongo and schema validation. I'm not 100% sure, honestly. Yeah. You'd still be storing your protobuf values, but the contract would have to be negotiated out of the database. It would have to be, the contract would be held in a proto schema file, and negotiated, validated in the client and server, or both points. So yeah, I don't see any support for schema validation via protobuf at any point.
Yeah.
But then I don't know. I don't know the complete roadmap, and I don't know. I'd need to have a look through the GitHub issues. I'm sure someone's probably raised it more than once.
And like with the way we work at Cockroach Labs, you could always like put a bug in one of the engineers' ears, and maybe they'll work on it as a Flex Friday project or as a Breather Week project. So a lot of like innovative features for CockroachDB get added because of these kind of fun processes that we have that gives the engineers a lot of flexibility. One of them that comes to mind is and I'm going to get the name wrong, it's the CDC query translation or transformations.
Yeah, CDC queries. So they used to be called CDC transformations, but now they're called CDC queries. Were they a Flex Friday project?
Yeah, that was a Flex Friday project. I mean, it was over multiple Flex Fridays, but somebody asked an engineer if it could do it, and they just kind of thought about it, and over time they built it out, and it got added as part of the product. So
it's great.
That's super cool. I love when companies are able to do that.
Yeah. Cool. Well, yeah. I think we're approaching time.
Yep.
Unless there are any more questions, it's thank you again. Yep. Always a pleasure.
Yeah.
Have a lovely weekend, everyone.
And we will see you in 2 weeks. Yeah. So, as I can't find the button. Oh, I was like, as your people across the pond say, TTFN. Ta-ta for now.
Ta-ta for now. Bye.